Inferential statistics pertain to taking a small sample of the population and then using that sample to estimate the characteristics of the larger population from which the sample has been drawn. One specific statistical test you can use to make inferences about a population is students' t-test, often just called a t-test. The t-test is used when you have a question about whether two groups are different. That is, you can use the results of a t-test to conclude that there are significant differences between the means of two groups, or between the mean of a single group on a variable and a specific target value that we are aiming for on that variable. Suppose, for example, our organization has instituted a new customer service training for its employees. And we believe that employees who take the training will perform better than those who don't. We now have a research hypothesis which might be stated: employees who take the training receive higher satisfaction ratings from their customers than employees who do not take the course. Here we're interested in two groups, those who take the training versus those who do not. We could design an experiment to test our hypothesis by assigning one random sample of employees to take the course and assigning another random sample to a control group that does not take the training. Let's suppose that after the experimental group, that is, the group assigned to the training, has completed it, they receive an overall mean customer satisfaction score of 4.8 out of 5. And the control group receives a mean score of 4.2. On the face of it, these values seem to support our hypothesis. 4.8 is greater than 4.2. However, as you may recall from our learning resources on hypothesis testing, the default null hypothesis says that there is in actuality no true difference between the groups. The null hypothesis states that the difference we have observed is simply error, or an artifact that's been created by our sampling methods. The null hypothesis suggests that if we drew additional samples again and again and tested them, we probably would not observe a difference between the groups in the population. Therefore, we must conduct a statistical test, the t-test, to determine if we can reject the null hypothesis and accept our proposed alternative hypothesis that our observed differences are reflecting a real difference in the population, that our observations are not simply sampling error. We use the t-test to test our null hypothesis. It requires either manual or computer calculation of the value of the test statistic t, which is in turn used to determine the probability that the null hypothesis is true. We call this probability the p-value. Usually, if the probability that the null hypothesis is true is less than 5%, or p less than 0.05, then we can reject the null hypothesis and accept our alternative hypothesis that indeed the means, and therefore the groups, are different. In this case, if our calculations reveal that p is less than 0.05, we could say employees who take the training course do receive higher satisfaction ratings than employees who do not take the course. We call this a statistically significant difference between the groups. One condition of t-test is that the dependent variable is measured on a continuous interval or ratio scale. Additionally, t-tests can be used only when the following assumptions are met or nearly met. The population from which the sample is drawn is normally distributed. Each observation of the dependent variable is independent of the other observations, and the variances of the group are homogeneous. This last condition is known as homoscedasticity, an ungainly word that you will see in discussions of t-test in the literature. Additionally, the t-test is most likely to correctly reject the null hypothesis when the sample size is large, when the sample size of the difference between the means is large, and when the population is relatively homogeneous or contains just a small amount of variation. When you read studies that compare two groups in the scholarly literature, you may sometimes encounter one of the non-parametric equivalents of the t-test, like the Mann-Whitney test. Non-parametric tests make fewer assumptions about the data than do parametric tests. So we use them when we cannot assume, for example, that the data is normally distributed, as is the case with categorical data. Overall, the t-test is a commonly used inferential statistic that you will need to know in order to conduct basic research. You will also see it frequently in the scholarly literature. It's important to understand why and how it is used so you can both conduct your own research and evaluate the literature appropriately.